Yeah, and we're back. So let's not waste too much time on the introductions, but when we first started with SaKE, I did not expect that we would have someone from Microsoft here. But like the last year, I feel that Microsoft is also getting a bit of his cool back and like really pushing forward new, good products, much more open, and yeah. So one of the reasons is that you're here now. So Jeroen, take it away.
Okay, thank you. So good afternoon, and indeed, kind of a bit surprised to be here. Wouldn't have happened maybe 2 years ago, I would say. So there's a big changes at Microsoft. We're changing as a company. We're changing what we do and how we sell and how we envision the world. We changed that. We don't believe that the Microsoft ecosystem is what it is and that the rest of does not exist. That's not true. We know that. We know that now, finally. You know, moving over a company of, let's say, 150,000 people, that's hard. So you need to really make a big change to get it into the heads of people. And that's what we did, right? So with changing, for example, CEOs and things like that. So my name is Jeroen Heerdt. I'm a technology advisor with Microsoft here in the Netherlands on BI, big data. So basically that means that I'm a data nerd. What I do as a job, I try to explain to customers and partners what our BI, big data story is, what we do not do, why we do not do things, and how it can help them moving forward. Okay? So I'm not a sales guy. I'm from the content. I've been a consultant all my life doing this kind of thing. So basically, I am in the sales organization, but I'm not one of the sales guys there. So to illustrate to you that I'm a bit of a data nerd, you know, when I drive my car spits out, let's say, from 62 sensors, a data point per millisecond. I get that data, store that data, and try to analyze it to relate it to my calendar, my schedule, to see if my stress level is any indicator of the amount of fuelage I make on a tank of gas. Right? So that's how far I go. And you know, I'm next week I will see the Microsoft Band, which is our smartwatch, which you probably never heard of, maybe you did. But anyway, the thing can calculate my stress level between 0 and 10 using tension of the skin. I'm looking forward to relating that to my driving behavior on road, right? So the other example is that I recently bought a house with my girlfriend a year ago, and we bought the house using Excel. What we did, we made a formula of what is important to us in a house, maybe safety, distance to work, distance to family, distance to greenery, whatever. Distance to highways, probably in my work. And there's a formula, and then the two entries were postal code and house number. And then Excel said it's red, green, or yellow. That's it. And the process we followed, we went to the website, we looked at photos, she looked at photos, and if the photos were good, she emailed me the link. I would look at photos if that was still okay, because that's the feeling with the house, right? You can't put that in numbers. If that was okay, we used Excel and got the red, green, or yellow, and using the red, green, or yellow, we went to the house, or we never went to the house. So that's basically how I live my life. Next step will be to hang Kinect cameras in my room to give everybody who visits me a doctor's prescription for what drugs they should get because they're suffering from certain diseases, which turns out if you have people moving around in a building for 10 minutes using Kinect, you can safely say they have Parkinson or whatever. So, so that's the lengthy introduction. Today I'm going to talk about machine learning, and maybe you don't think about Microsoft when thinking about machine learning. Well, we have been at it quite a while. We do have a search engine, you know, maybe. And that search engine is built around machine learning. So we try to optimize the search experience for every single one who goes there, try to optimize what you get as a result. One of the other examples here is traffic. We do machine learning on predicting traffic flows. We're actually one of the best companies in the world to do that. Funny story here is that we use this data to drive political campaigns as well. So there was in the US, there was a politician saying it's going great in my country. It's going great in my jurisdiction. Perfect. Everybody has a job. Well, turns out our traffic data showed a significant uptake in the amount of people during a normal working day at the shopping mall or where they could get new jobs. So it was not true. So we published the data in a newspaper and he had to bail out. He had to rephrase his words. Just, you know, he was making stuff up. We could show with the data that's actually not true. We have been doing big data or data mining and machine learning for a long time. If you have worked with SQL Server, maybe you recognize this screenshot. This is basic data mining in SQL Server, which of course is also built in Excel. So if you have Excel, you can do a lot of stuff already. But that's kind of backwards. And I've been mentioning this device as well. This is the Kinect sensor. It's 150 euros if you buy it. And it's basically it's a big, well, it's big. It's a monitor. It's a video infrared device who can monitor skeletons in a room. And what it does, it will allow us to identify the skeleton in the body. In the video, we see the body parts. We see how they stand for in orientation to the camera. We see the force on the muscles, how you move, and we even do heart rate monitoring and expressions with that single device. That's machine learning to the top. There's no forewritten software here. It's just an algorithm looking at what it gets and trying to predict what's going on. One of the examples here is that we use this actively with people in the movie business to decide to skip or show scenes of a movie. So imagine you're a horror movie creator, maker, and you want to know how involved the person is in a movie. We use this data to give you a score between 0 and 10, and on that score of involvement, you can decide to show or skip a scene. Right? So if you're sitting like that, watching a horror movie on your couch, we know, and we will show you that horrific scene. If you're like this on your couch, all crouched up and almost crying with an elevated heart rate, we will skip the scene. That's actually happening today with this kind of device. Then while we're at gaming, who of you knows this guy? There we go. He loves machine learning, right? What we do, if you play Halo, we will directly in real time change the environment, the amount of enemies and the strength of the enemies coming towards you. Real time, all the time. There have been more minutes spent in Halo than in, I think, maybe all worlds in the galaxy, if you would consider other worlds than ours. So that's so many hours, it's just breathtaking how many data that comes out of there and what you can do with that kind of stuff. And then this girl, you also probably know, right? Cortana from the game. She's our digital assistant. She helps me being on time everywhere. So she will tell me that there's traffic on using the aforementioned search engine. She will tell me that I have to leave. This is also the person, or person if you want to talk about a person, I don't know. But she holds the world record in predicting soccer games. It's better than octopus pole. Really. So I've been trying this kind of stuff without machine learning, because this is machine learning, right? And oh wait, we tried that. Everybody knows this? Microsoft Bob, right? This was our first crack at doing a digital assistant before we even knew about clustering and regression and whatever. This is a piece of software which was officially built by Melinda Gates, which is the first and last piece of software she ever built for our company. And so what this is basically it's an assistant, but it's a very stupid one. So what it does, well, this friendly interface, but what it tries to do is, hey, you're writing an email, so let me explain what an email is. Okay, so it tells you, it's kind of a digital mail, blah, blah, blah. The stupid stuff, thing, if you have that once, and you send a second email, you get the same explanation, you can't skip it. The third, the fourth, it doesn't matter how many emails you send, you'll get the same stupid response. Okay, so this was really bad. And then we tried to improve a bit. You got Clippy, of course. And so that kind of improved. Now we're up to the level that even our own personal assistant now makes fun of this guy, right? Clippy, what's not to like? That guy took a heck of a beating and he's still smiling. That's actually a question you can ask to Siri and she will tell you this, or another joke about Clippy. And one other thing we're working on is this technology. You know Skype probably, right? Never heard of Skype? Don't think so. But Skype is great at connecting people, okay? But what if there's a language barrier? Couldn't we do like the universal translator? Well, we can actually. So that's what we're working on now. So this is Skype translator. Basically what's going on here, this guy is talking Spanish, and this is, I don't know what, something else, I hope. Otherwise I ripped the wrong screenshot. But so basically the idea is you talk two different languages, and everything you say goes into the other language at the other end, and he will talk in his own language, and you will get synthesized in your language what he's saying. This works in real time. This works now for, I think, 15 languages, and we're ramping up the languages every single day. This is technology coming out probably, it's now in preview, but it's coming out like maybe this year for everybody to use. So that's pretty cool technology, I would say. Okay, so that's Microsoft and machine learning basically on what we do in our own products. But we don't only make products. We also sell a platform for others to make products. Basically, that's our biggest game, right? The platform, not the product. So that's where our biggest platform, or one of the biggest platforms we have, is called Azure. Everybody familiar with Azure or not? Not so much. So Azure is a public cloud, basically. Azure is a way to rent big machines. We have 19 data centers across the world. You can rent compute power. You can rent virtual machines if you want. You can do storage, but you can also use other services like mobile services or media services or CDN services. Or if you want to go to, for example, analytics, you could run Hadoop in there, which is called AG Insight, you know, marketing, funny naming, whatever. But it's called Hadoop. It's the Hortonworks distribution of Hadoop. And you can do machine learning, you can do stream analytics. The speaker right before me was talking about Kafka. This is basically the light Kafka version, where you don't have to know all the code. It's not as good as Kafka, don't get me wrong, but it's for the poor man's stream analytics, basically. No, we try to do. We make it easy. You don't have to write code. If you have to, you know, if you need more, you can use Kafka using Hadoop or the AG Insight installation and write code. Data factory, event hubs, all that kind of thing are in here. So this is for IoT scenarios where we read sensor data. We can do a lot of analytics on top of that. So here I want to focus on machine learning here. So basically what we do in machine learning is we try to, I'm going to say that politically, maybe topple the market a bit, because there's things happening, right? There's two big companies in the data mining machine learning space, and they've been sleeping. And there's new technology like R, Python, and they're not doing anything with that. So why not do we try to do that? And maybe see if we can steal part of their lunch. So that's what we're aiming for here. So what do? Well, we help you ingest from any data source, AZ Insight, SQL Server, Oracle, DocumentDB, blobs, whatever you have, JSON, doesn't matter. And we allow you to use a simple workspace to get data into there and do advanced modeling using machine learning. And from there on, you could publish what you build in, it says minutes, it's now down to seconds, it's one mouse click, to publish what model you have into a web service, both OData and WCF. So what it will do is allow you, for example, to build a very simple app that just talks to the web service and brings the magic of that algorithm, the magic algorithm you build, right to the user. The click of publishing this is just one click. This is magic. You know, the big companies I was talking about, they will charge you 400,000 euros just for that. We do that free. So that's our biggest change here. So what do we try to do? We make it easy for you to start. You don't have to buy a server or whatever. You'll get a good investment on what you already have. So if you already used R or Python, you're welcome. We have other algorithms for you to use, but you don't have to. And as well, as I already said, you know, making it in a web service, let's call it that way, I'm not going to pronounce it again, is a matter of a click. So the other thing here in this is Revolution Analytics. Anyone heard of them? Never? Are there no R programmers here? You should have heard of them. Okay. So there's some people heard of them. So basically, Revolution Analytics is the only commercial reseller of R. It was, or it still is, because it's now part of Microsoft. So Microsoft is now the only commercial reseller of R. So what these guys do is basically take R, leave it as it is, but add R. Because R is very limited, for example, on the number of cores you can use. So if you have a multi-core machine, R will only use one. That's stupid. So why don't you have software that runs on 4 cores? So that's what we did with Revolution Analytics. This is an announcement that has been signed only like a week ago. So I'm not allowed to talk about how do we actually integrate this kind of stuff into our software, but it's out there and we're moving in this space. So our vision to data scientists with this software is, and these services is, we need to enable you to make a bigger impact in your organization. So any data you have, any data that's stored in Hadoop or in your data on your desktop or wherever, you can analyze it. You can choose what you want to build. Do you want to use our modules or do you use R or Python? You're welcome. That doesn't matter. You can do that as well. You can mix and match what you have built or what you bought or rented with others, and you can share your workspace. And basically here again we say we really like the one that we make it operational in a web service. So here's again the third time, will be the last time I think. It will be on the slide. So basically build your model, bring your technology, the knowledge you already have, build your model, let our data centers do the heavy lifting, and you only pay for what you run. So you pay, I think it's close to 12 euro cents, something like that, per run, which is pretty cheap, I would say. So with that, let me show you a bit of a demo on how the ML Studio works. So you should be able to see my screen now. So this is the studio. It's studio.azureml.net, and it's basically the environment where you create new experiments or connect to data sets. So you can create a new experiment here, select new, do a blank experiment, or open one of the big library of experiments we have set up for you to give you a head start. There's also a link to a gallery where you can find both free and paid sample experiments. The company's doing, for example, fraud detection, but you have a very specific algorithm, they sell it there. So the only thing you need to do is go to the gallery, buy the algorithm or rent it through the store, and you have the algorithm for you to use. So I can create a new experiment here, and it's typically Microsoft software, right? It's drag and drop. So what you do, you select from the left side, which is a whole library of things you can use. You drag them and you connect them up together, and you do some property setting if you have to do that. So basically, I can connect to a data set. I have saved data sets here, or I can connect to a data set using a reader or using just typing, which also is very interesting. So I drop the reader and I can specify which sorts do I want. So blob store, OData feeds, tables, SQL database, Hive queries, whatever you want to do, web URLs. And from there on I can do the data transformations, formatting conversions, and all that kind of stuff. So data input, data transformations, filtering, sampling, splitting. I'll show more of that in a second. Then the machine learning algorithms. These are the algorithms we, whoops, wrong button. The algorithms we provide out of the box. And between these are some of the algorithms we use, for example, in the Kinect, or algorithms we use in Bing, or others. And some of the algorithms, for example, the boosted decision trees are world-class algorithms. They are faster and better at scoring problems than any algorithm in the world. So they're here for you to use. Just drop them and connect your data up, and there you go. And you can run the experiment. So what else? OpenCV. If you want to use Python, you can use a Python script here and just copy paste the data here. So upload or connect to Python files, so it will be executed automatically. You don't have to re-upload the code, because this is kind of a code breakage, right? You have your code here and you upload it here. So basically what we want to do is let you connect to the file you have somewhere, and if the file gets updated, we'll just use that new file. Same goes for R. If you use an R script, you can answer or connect to the data here. So I'll show you an example of that in a second. Analytics, and there should be some image analytics as well somewhere. I don't know where. Oh, here. So this is the image reader, right? So if you want to do, for example, skeleton detection in an image of a security camera, that's where you go. Pull over the image reader, drop the connection, and you're done. an experiment is automatically saved, you can save it as well, or save as, you can run it here. What it will do, it will spin up virtual machines big enough to run the experiment for you. You can prepare a web service just by clicking that magic button there, and it will do the web service analytics to change the web service for you. So going back to one, for example, let's do, I don't know, what do we do? The R. So this is a very simple example of what R code can look like. You know, here's some R code. Basically what it does, it connects to the dataset through the input port. It connects the dataset to the dataset of the the data frame, and then you do a mapping, a plotting of the data, and you output the plot. And the output of the plot is then running right, should be running right here, which is not. So that's interesting. So let's see why. So I'm going to start this right now. So it will now generate the plot, and if we have time, it should be generating a plot within a second. So this is basically how you can easily integrate R scripts right inside of this It will run in the background. We'll see if it comes back. So that's basically the generic idea here. You have your web services to manage. So if you have any web services published, you can go here and look at them, and also set up marketing as well as financing around it. So with the web service, you can specify how many calls, for example, a user can make within a certain amount of time, and also how much he needs to pay for it. So let's say you do, I don't know, 50 euros a month for €5 a query. That's totally up to you how you do that. So let's hope it's finished right now, or not. It's still running. Come on, you're slow. Okay. Anyway, let's go back to the slides, and we'll see if we. Oops. We can see that later. Okay, so some samples and some lessons learned about what we did with this kind of technology here in the Netherlands, both in the Netherlands as well as outside, but things I've been personally involved in. First example is the MOT test, right? The APK here in the Netherlands. You know, you all know how that works, right? You have a car, you bring it to a service station, they will do whatever they need to do with the car, and they will then certify to another party saying this car is okay, right? In the Netherlands, we have people, and I assume it's everywhere in every country. In the Netherlands, we have persons walking around whose job is it to randomly pick out the cars that gets checked and say, hey, I need to have a look at it, right? To check if the garage owner is actually doing a good job. So here's the problem, that randomness is not random. People are used to normal ways of behavior, patterns. Even if they don't know, they will use patterns to decide. So basically what turns out is that we now know that it's not random, the checks, as well as the car dealers also know that. They knew it before this MOT organization did. So what they would do is, if you have a bogus car, but you still want it to be through the line, so not checked, right, for any problems, you will have to first certify 5 cars, and then the 6th car will be the rotten apple, right? You know that because the people doing this kind of job are just persons. They will follow a certain pattern and never get the 6th car to check. Never ever happened in the whole history. So just by doing that, we figured out that this is actually happening, and we kind of changed the way these people behave so that it will be now more random. So now there's a piece of software saying to the guy driving around in the country going to check cars, where he should check. We're not leaving it up to him anymore. We get software that says to him, you need to go there, there, there. So it's more random, and not letting him do it. So that's one simple example of what we did quite recently. So the other is the call center. This is about an organization here that is very dependent on call centers for helping people. And what they have a problem. They can't get a lot of prediction on how busy it will be, but call center agents are very expensive. Well, they're not very expensive, but if you, let's say, if you dial a call center agent bureau 5 minutes before you need one, you'll pay a big price, right? And so probably what you want to do is say, a week in advance, I need this amount of people at that time, right? It will be much cheaper. So we want to do a call center prediction here. And also, what these guys did, if we figure out when you're going to call and how many times you're going to call as a new customer, if it's more than 5, this company decides they will call you. Why? Cost reduction, right? You can plan when you want to call the person. And also you can specify how much time a call center agent will spend on that call, right? And also, because this is a sensitive subject, these people are trained to listen to the story of the person they call, to kind of let them weep out and feel okay and understood, okay? And so there's two effects of doing this. One, they save cost, no expensive call center agents anymore. 2, they're actually perceived as being a nicer organization because they spent the time to listen to people. And that has been, that decision to do that has been based on an algorithm we built in half a day for them. Which is kind of scary, by the way. Oh, here's the R script. So visualize, and there's the plot. Woohoo! No? Oh. I find it pretty cool. Because that's new to us, right? Doing this kind of stuff. The R. So here's the call center prediction model. So what you'll see here, we have a training experiment and a scoring experiment. The scoring experiment is the one that's used for the web service to run. So, oh, this is really not readable. And let me go zoom in a bit. So what it will do is we'll get data for the call center prediction, do some quantization, projection, and editing of the metadata, and then it will split, classic approach, right? Split the data set into a training and a scoring set. And then it will use 1, 2, I think 4 different algorithms to try to see, you know, if one of those algorithms, which one is the best. So we dynamically choose between the algorithms you use. So here's a 2-class decision forest, 2-class boosted decision tree. There will be a 2-class logistic regression and a support vector machine, all competing to give the right score for this certain amount of data and information we have. So we train the model right here, and then we do a scoring. So scoring would be, you know, just scoring the trained set, the trained model with the trained set against the test set. And then we do an evaluation. So big problem here is that, and that's kind of a funny story. I told this to the persons building this. So what you see here is you have only the option to connect 2 models, right? So if I go here and I drag one line from here to here, there will be only 2 connection points for me to choose. So what if I want to compare more than 2 models? Right? Normal question. You can't do it. So basically, when I asked this, it at me like, yeah, but sure, you don't want to compare more than 2 models, right? You know what you're doing. No, probably not. People using this probably don't know which algorithm to choose from the start. You need more ways to give people more models to compare. So basically now we only can compare 2. So I can see the RSC curve and things like that, lift and uptake. Come on. Still Microsoft software, right? There we go. So here's the scored data set, the one, the blue, and the red line, and you see how they compare. The blue is obviously doing much better. And you can see the false and true positive rates, accuracy, precision recall, things like that, and you see a sample of the data. So this is how you develop the right model. And using the scoring experiment, you will then do a web service. There we go. So the web service is here. So the web service input, it goes to the scoring. You have the trained model, which is dynamically trained based on the other one. And then the scoring will be done, and the input will come from the web service, the scoring will be done, and the output goes through the web service outside to basically here a CRM system. So there's a CRM system sitting here, a new customer comes up in the CRM system, and the CRM system sees that, will call this web server, score how many times the person will call, put that into the CRM system. The CRM system will then make a list of persons to call because they will call too much in the future. So that's pretty nice. So then we had some issues. And this one is really, really interesting because, well, I found it interesting when I ran into it. So think about the call center again. This sounds like a pretty generic problem, right? Predicting how much load there will be on a call center. You should be able to apply that anywhere. Well, it turns out if you do that, for example, for organizations that help people that have broken cars along the road, it sounds like a perfect solution for them. They can plan how much call center agents they need. Well, problem is, this was all built on a prediction. It was built on a prediction of a prediction. Because we were using weather forecasts, which in itself is a prediction, to build a prediction on top of. You can see where I'm going? So, and it takes some time to get in their head because they didn't understand that what comes from the National Bureau for the Weather is not a fact. It's a prediction about how the weather will look like. There are errors in there, right? So if you use that as a truth and then do a prediction on top of that, you get a crooked house. You don't get any results. So never ever do a prediction on top of a prediction of a prediction. Well, that doesn't make any sense. So this is pretty hard to spot. Here in this case it was okay, but in others it was pretty hard. And the others is machine learning is no magic and no silver bullet. And probably your reaction right now is, duh, of course it's no silver bullet. But people don't know that. So basically a customer that does baggage handling on many airports in the world came to us and said, you know, we have got these machines and we want to know when they will fail. So then we have less downtime, right? If we predict the maintenance upfront or the failure, then we can do maintenance upfront so they don't have to have all the downtime. And we have the spare parts ready and things like that. So it sounds like a perfect solution, great. So anyway, yeah, we have all the data about errors and what it's doing, okay? So let's see what we had. Okay, so this is just 4 samples from actual machines, by the way. Maybe. We don't know, right? That's the problem. And even they started looking at it like, okay, so this is what you got? Yeah, this is the actual payload of the message. And there's really no way to make any sense out of this. Well, there's one way. You can see closer, you will see S, X, and Y, and Z. So that's X, Y, and Z are the axes on a plot where the machine is. So that's basically the only thing we got from this. But you know, you don't have to understand it all. You know, you don't have to understand all of that, but you need some basic consistency and same pattern across devices. Because these are 4 logs from, I think, the same crane or 2 cranes in the same type, in the same environment. But they're totally different. You can't parse this automatically or whatever. You can't do anything with it. But of course, if I know that this message will say that let's say the flywheel is broken, then I don't have to understand the message as long as I know what it means. But you know, it's kind of hard to work with this kind of data. And they even didn't know that they had this amount of software and different versions in their cranes. So with versions in the cranes, they had different written software. Even the engineer assembling the crane would go in at the moment he assembled the crane and set it to power to change the software, right? Then you never get a consistent set if you allow a person to change the software on the fly. So this is the biggest problem here. We can't do anything with this. So no silver bullet. So question, what is this? Sorry? Yep, sounds good. So heart rate, okay. So what can we see? Is it okay? Heart failures, maybe? So basically what you see, the first part here is a rather normal, steady pattern, right? It's probably from a child because this is pretty fast. Normal persons would maybe be a bit closer than this, but still a bit space between there. So that's a child. But then it slows down, and then we see this big spikes, and well, the data never continues, so you never know what happened after it. So basically what this is, what you're looking at, is this guy. And these are pre-born babies in the hospitals, and what's the problem with babies is that the normal way of treating them, you're always too late. Because you read the heart, you walk up to the bed and you see what's going on now, you're too late already, if it's going wrong. So if you're ready here, whoops, if you're ready here and you see that the heart rate is going up, you're too late. Because what happened is that in this analysis we did is that this would be the normal pattern, the first one. Then there's kind of a silence before the storm pattern, which is where, you know, the body kind of protects himself, maybe. I don't know for a better description of that. Kind of sit tight for worse things to come, right? And we label that problem, for lack of a better word. So basically, you know, if the nurse comes in right here, it's too late, because after this the baby dies. And so what we want to do is we want to monitor the silence before the storm. We want to dynamically identify when the silence kicks in, because if this is slowing down and it's indeed a normal silence before the storm pattern, we need to let the nurse know that's now the time to act and not when she comes around again. Big data or this kind of thing saves lives. This is done all over the world in hospitals right now. Okay, so maybe a bit less bizarre energy prediction. And I'm gonna have a little fun here with a colleague of mine, because he was as stupid to give me access to his energy prediction model, which is actually live coupled to his thermostat at home. So what he's trying to do is get a prediction based on earlier behavior of what the temperature of the thermostat should be, right? So if it's in sleep mode or in comfort mode, basically two choices, binary, right? So, and here you can see the score. There's two models being trained here, and we can look at the score, for example, to see how well it's doing. It's not that good, but it's about, whoops. So this is the scoring. So 9 times out of this simple set we had it correct, and then 5 times as well for comfort versus sleep, but also 5 times we predicted sleep, and there was actually comfort. So here is where the thermostat went to cold, where actually they were still awake. And he used this to make a web service out of this, so he can actually take his phone, and that's where he went wrong, because I can do that as well. So I can go to the phone app. So now this phone app will allow me to change his thermostat. It won't go as high as 24, but you know, doing this, and so here's some sample curves, right? And I can use, when I click on one of these tiles, what it will do, it will call the web service and figure out, using the last half hour of the day, which is represented in the tile, what the setting would be. So let's see, this should be sleep, I guess. So I'm clicking it, hoping that the internet works, and if we're lucky, we get sleep and the thermostat, oh, comfort. So it's comfort. So it goes to 22. So now it's not 24 anymore in his house, it's going to 22. And let's go to the other one. Still comfort. Ah, come on, should be better. I want to have sleep. And then I get too many requests, I know that. Because what he did is he also knows that colleagues are using this, so he doesn't want his thermostat to be wobbling all the time. So this is a part of the marketing here, right? He set a cap on individual users doing too many requests per second or minute, right? So that's what's taking in here. So it's no fancy code, it's just the web server saying, you did too much. So let me try that again. No. So basically what should have happened, if I click the right one, because this changed on the fly, it should be set to 15, and he should be pretty darn cold. So that's a simple sample of what you can do with these kind of things. And okay, how many minutes do I have left? 2. Wow. Okay, good. I'm almost at the end, so that's good. Let's see, what else do I have? Energy prediction, I showed that, I showed you the scoring, yep. So I had one more sample here for you guys for shops. So a home deco shop, basically we worked with. They invented apps to allow their customers to use this kind of technology. And we masquerade this is the actual app, but we change the logo and the name. So basically what I can do here, I can log into the app, and I can I can identify myself as being one of the customers, and I can check in the store.
John. Let me show you a list of products tailored just for you.
So what is going on now is it's using actual, shut up, next best offer algorithm in the service to calculate what John has bought in the latest instance, and then find top two categories for him to buy and do a recommendation on top of that. So this is should be pretty fast. If not, we'll skip it. Oh, there we go.
John, here are some products we think you'll love.
Okay, so John gets pillows and cocktail glasses.
Check out one of those earmuffs. We've got some cool designs.
Okay, so this is okay, but you know, lots of companies do that. But they went a one step further, which is the last thing I want to show. They actually built another app for employees. So here's Miguel logging in, and he can see, you know, how it's going, how the restock is doing, and whatever. But what they have in these shops, they have Connect cameras hanging around in the room. And if a person is looking for help, they will send a notification to the nearest employee with the app on his phone. So here comes the notification. I hope. Come on.
Miguel, there is a customer in the candles section who could use some help. They have been there looking for 3 minutes.
So this is just the Connect camera noticing that you're looking like that blankly to a shelf. And then he can say, okay, I'm going to attend, or I'm not going to attend to the customer. For sakes of demo, I'll say, okay. So here's a map of the store the customer is in, right? And because we know this customer, he doesn't need to know if it's Lucy or John or whoever or what the age is, but what he needs to know is upsell, right? He needs to know what this customer is interested in. Well, you know, but probably something else as well. So if I click on this, it should tell me.
Miguel, suggest that the customer in the candles section might also like to access these.
This is again based on the knowledge we have of that customer and what he bought in the latest instance. So with that, I'm going to wrap up, and I need to show you the legal slide, but I'll show you this slide as a wrap up. You can look at it for later, and I'm obliged to show you this slide because otherwise we'll get fired. Thank you.
Okay, amazing stuff, thanks. But before you do the translation, could you fix calling with link first? 'Cause that would help us tremendously.
Yeah, that would help, right? Yeah.
Yeah, or do Dutch to Finnish translation, that would also help.
Yeah, that would be great to do, yeah. It would be hard, but.
Before we go to dinner, any questions? No one dares to?
So it's either crystal clear or completely irrelevant.
Or they just want to break for dinner?
That is also a good reason. Yeah.
No one? Oh.
Okay.
Okay.
Oh.
Then thanks again,
Sure.
and talk to Jeroen over dinner. Then
Yep.
we'll be back in 40 minutes. So yeah, enjoy your dinner.